firstly, what we can determine from the question is the value of h. So from the get to go, what we can see over here is that m plus m is greater than is less than equals to ha. Since m has a value of 0 to 9, so it will have since m has a value of 0 to 9, h will always be 1. This is because when we add two single digit number, the highest carry on we can get is 1. So if we assume m and m to be the greatest value possible for each of these digits, so like if m is 9 plus 9, we can get 18, so h will always be 1. Even if we consider a carry on of 1 from adding a plus a, we get 1 over here, which we will add over here, we'll still get 19. This is the highest possible value we can get for ha, so h will always assume the value of 1, so h is equals to 1. When h is equals to 1, we can see here that h plus h is t, so t will be equals to 2. Similarly, t plus t is equals to I, so I is equals to 4. Now we have to determine the value of b. So from this question, since we know this value of this one, we can take this out, so we'll get ma plus ma. We are taking this out because there are no carry-ons from this part of the equation, so we can get ma plus ma is b a h, and h is 1. So what we can take out again from this equation is that 2a is equals to b. So from this conjecture, what we can know is that since b is 2 times some integer a, b is always even. So b can either be 0, 2, 4, 6 or 8. B cannot be 2 because t is 2. B cannot be 4 because I is 4. So b can either be 6, 8 or 0. So let's try each of these values of b one by one. So if b is equals to 0, a can either be 0 or a can either be 5. A cannot be 0 because if a is 0, b is equals to a, and that is not possible by the condition in the question. So a is not equals to 0. So when a is 5, we get 2a is equals to 2 times 5, which is equals to 10. So b will be 0 and we'll get 1 carry on, so we'll take that carry on and add over here. So m plus m is equals to m plus 1 is equals to h is 1 and a is 15. So 2m is equals to 14. That is possible because we get an integer value of m that is distinct from other alphabets in the equation, so m is equals to 7. Now let's see if the other values of b works or not. If b is equals to 6, a is equals to 3. So if a is equals to 3, we get that 2m is equals to 13, which is not possible because 13 is not an even number, and if we divide 13 by 2, we get some decimal even number, and if we divide 13 by 2, we get some decimal value, and we know that each letter represents a unique digit, so the value of m cannot be in decimals. So let's see if m is equals to 8. If m is equals to 8, a is equals to 4. This is not possible because a cannot equals to I. So the only possible value of b is 0.